Oh, hello. So if you're watching this video, that means someone has assigned you to watch this video. So what I'm going to cover here today is subtopic 5, displaying data. So basically I'm just going to summarize the gist of this subtopic, which is how to draw a table or how to look at tables and graph. And then we're going to interpret measure of central tendency and measure of dispersion. So without further ado, let's begin. Now the very first one that I need to demonstrate to all of you is called the frequency table. So usually you have a bunch of raw data, exhibit A. Alright, and you want to categorize those data, or at least tabulate those data in a way that's easier for you to analyze it later on. Okay, so assuming we are asking a bunch of students or a bunch of samples to rate how happy they are from 1 to 6. Okay, so these are the responses that you have gathered. Now, how are we supposed to interpret this? That's where frequency table comes in. So the 1 to 6 here are the rating. So I have 1, 2, 3, 4, 5, 6. Easy. For the next column, alright, you need to note down how many of the samples answer 1. So there are 3 of them. How many of the samples answer 2, 3 to 6, so on and so forth. So a frequency table is the easiest table that you can draw here. Okay, I'll just leave it here for you to have a look. Okay, moving on to the next one. So now I'm going to demonstrate to you a bar chart or bar graph. Alright? So I assume you have learned this in high school, okay, or secondary school. As usual, you have the x-axis and the y-axis. These are for your variables. Okay? So when do we know to use a bar chart? Usually, you use a bar chart when your variable is categorical. Meaning, the variable that you're trying to measure can be categorized. For example, the type of food that we love to eat, the type of subjects or the course that we want to choose. So these things are categories. Okay? So meaning when in your x-axis here, alright, it usually is a category. So for example, the type of food that people usually eat in Malaysia in the morning, you have nasi lemak, nihum soup, I assume roti canai. So these variables are categorical. That means they have nothing to do with numbers. So now the y-axis will be the numerical variable that we're going to look at. Okay? So when it comes to categorical variable like this, that's when you use a bar chart. Otherwise, most of the time we will be using line graph or frequency polygon. Okay? Now, the thing about bar chart is that you can put in as many subcategories along the way. So for example, let's say I'm looking at the overall Malaysians who love to eat nasi lemak, mee hoon soup, and roti canai. Okay, now what if I want to look at male versus female? Okay, that's when I just add another category here. Alright, so usually in such case, you might have to do some labeling. So for example, in the first one, I'll put stripes. Whereas for the second one, maybe polka dots. So when you have a few subcategories that you want to label, so on the top you have to indicate the ones with a stripe, what are they, which is male, and the ones with polka dot, which is female. Now, of course, you have the liberty to label however you like. It's really up to you. Alright? Now, one thing when it comes to bar chart is that as you draw along the axis, make sure these things are equal. Okay, so if you look at here, okay, I mean, I'm not drawing according to scale, but if you look at this one seems a bit long. So you have to make sure that every space is the same for all of this on the axis. Alright, so this is the bar chart. Now, the next thing we're going to look at is called the line graph. Okay, so when it comes to line graph, usually both the y-axis and the x-axis are continuous variable. Okay, that means they are usually numerical. They are usually something to do with numbers, unlike the one that we looked at previously. So, a line graph, as the name suggests, there is a line that you have to measure. Okay, you have to plot on the graph. So, for example, let's say x-axis, we're looking at days of the week. Monday, Tuesday, Wednesday, Thursday, Friday. Okay? For y-axis, maybe we're measuring the number of times, the number of hours of TV that I watch. Okay, so Monday I didn't watch as much. On Tuesday I watched a lot. Then on Wednesday, so on and so forth. Okay, so this is a line graph. Now, remember this, line graph, both sides, usually we have a continuous variable, meaning it doesn't end. So if you think about numbers, right, number doesn't end. It can continue onwards. So days of the week as well. It can continue to the next Monday, to the next Monday, Friday, so on and so forth. Same goes for the months, January, February. So you have this year and then you have next year as well. So it's a continuous line. Now, when it comes to line graph, right, it is very similar to another graph that we call histogram. Okay? In essence, histogram is a line graph, but just that you draw it differently. Okay, when it comes to drawing a histogram, first thing first, you must leave a little bit of a space here, which should be the same size as the bars that you're going to draw in a short while. So, a histogram will look something like this. Essentially, it's a bar chart. Essentially, a histogram is a bar chart, just that instead of leaving space between each of the bars, you connect them. However, at the front, you have to make sure that there is still the same amount of space as the bars, as such. Okay? So, now why did I say it's the same as a line graph? Because if you were to put the plot here, like for example, in the middle of the bar, you can actually create a line graph similar to just now. There you go. Okay? So, this is a histogram, and histogram uses continuous variable as well, unlike bar charts, which uses categorical variable. So, the next one is the pie chart. Now, a pie chart usually won't be asked in the exam, as far as I know, but you still have to learn it anyway. And in psychological research, we rarely use pie charts. We would tend to prefer the ones that I have introduced earlier. So now what happens in the pie chart? A pie chart is the easiest thing here. You just gotta draw a circle, alright, and look at the percentage of the data presented. So Roti Canai has the highest percentage, so I will expect half of the pie chart to be filled with Roti Canai, like this. As for the other two, so you have to kind of approximate or agak-agak trying to create the number. So this will be the 20%, which is mee hoon soup. And this would be the nasi lemak. So pie chart is as easy as it can go, which is why I generally feel that it won't come out in exam, but you know, you gotta study it anyway. Hi everyone, so the next thing we're gonna look at is called the scatter plot. Alright, now the scatter plot is basically how we tabulate data and display it for correlation purposes. Okay, so usually this is meant for non-experimental research. Alright, so for instance, let's say our aim is to determine if a taller height indicates heavier weight. So in such cases, right, alright, the first variable will be the x-axis, whereas this variable will be the y-axis. So let me write this down. So here, because we want to investigate the height first to see whether it has anything to do with weight. So the height will be on the x-axis, whereas the weight will be the y-axis. So that means we have a graph that looks something like this. Okay? So as you can see, we want to find out whether higher height indicates heavier weight. So this is what we call a scattergram or a scatter plot. Alright, there are two names, scattergram or scatter plot. Now it kind of looks like a line graph, but it's not really a line graph. So one thing you have to know about this is that you do not connect the dots. Never ever connect the dots on a scatter plot or a scattergram. Okay, so we want to see how strong the relationship is between these two variables. So based on this, it seems like it's a little bit strong. Okay, now before I get there, there are two things you need to know when you are looking at a scatter plot. Okay, firstly, you need to know the direction. Direction is basically, there are only two answers, which is either it goes positive, going up, or negative, meaning going down. So here we have a positive relationship. Okay, so in direction, it either goes up or it goes down. If it goes up, it's positive. If it goes down, it's negative. Okay, the next thing we need to look at is the strength of the relationship. Alright, so with that, I'll bring you to this thing. Okay, now for the strength of the relationship, usually they will provide you this thing, this number. Now this number is called the correlation coefficient. Correlation coefficient. Okay, so the correlation coefficient can only be between positive 1 to negative 1. Alright, positive 1 to negative 1. So in between, it only falls within this number range. If it's positive 1 to 0, that means you can expect a upward kind of graph, which I explained here. If it's negative, then expect downwards. Now when it comes to the strength of the relationship, it's either a perfect relationship, but almost this never happens in real life, or there is no relationship. Now those in between, okay, it says here high, but the word that you should use is strong. So there's a strong positive correlation, meaning you can somewhat see a straight line, but there's things scattered here and there. Okay, the next one is called a weak relationship. Okay, weak relationship. Alright, So the same things goes for the other spectrum. If you see something like this, then it's weak. A weak negative correlation or a weak negative relationship. So this one will be a strong negative correlation or a strong negative relationship. Alright, so when it comes to scatter plot, you just need to know the direction and the strength. Sorry, I misspelled strength here. Okay. Now, in exam, usually they will ask you to draw a plot like this. Okay, so there is one thing I need to mention here. It's that always start from 0. Okay, so meaning when you draw, okay, so there's a slight error here for ways anyway. Always start from 0. Okay, so meaning, so you have to make sure the scaling is right. So if you start from 0 here and you want to make sure that it's like consistent, so 0, 2, 4, 6, 8, blah blah blah. Now don't worry about this. The number here is large. Okay, that's why it didn't start from 0. In Ways exam, they will usually make sure that you can fit the whole graph. Okay, the graph provided. So you just need to remember that when you draw a scatter plot, always starts from 0. Otherwise, the direction as well as the strength, these two are important too. So continue from where I left off just now. Okay, so how do you know whether something is weak, moderate, strong, or perfect? So if you look at here, this is your indication. If it's 0, that means there is no relationship. If it's weak or 0.25 to 0.50, then it's weak. You can put either weak. Moderate should be somewhere from 0.5 to 0.75. Okay, anything above 0.75 to 0.90 should be strong. If it's 1, that means it's a perfect relationship. So this is the strength of the correlation. And with the correlation coefficient, that's how you know what is the strength of the relationship. Now, finally, I want to talk to you about measure of central tendency as well as measure of dispersion. Okay, so measure of central tendency, there's only 3 things you have to remember: mean, median, mode. All right, you actually learned this before in high school and you just need a refresher. So to summarize this, mean is basically the average score of the entire data set. Median is whereby you have to arrange in ascending order and find the middle number. Mode is the one that appears the most. And fun fact, mode is used when there is a categorical variable. Okay, mode is used when there's a categorical variable. For example, what is the favorite type? What is the person's favorite type of music or food? For median, you only use this when there is an extreme score, meaning the score, the number, one of the number appeared doesn't fit in with the rest of the number. Otherwise, most of the time we'll be using mean. Okay, so I want you all to look through this in your OneNote 5.2.1 to look at this example to get some ideas of how to calculate this. Okay, the next thing is measure of dispersion. Now, measure of dispersion is somewhat more difficult to understand, but it's you don't need to know too much because we are not really a statistic class. You just need to know like what does the number mean and what does each of this mean. So we have range, variance, and standard deviation. Most of the time we are using standard deviation. Okay, range is basically the largest number minus the smallest number. Variance is the square root of standard deviation. Variance is basically, okay, if you can see here, variance is basically the square root of standard deviation. All right. Okay. Standard deviation is the square root of variance. Okay. Standard deviation is the square root of variance. That means variance is the square of the standard deviation. Okay. So I don't want to confuse you all too much. You can read this on your own. But basically, we just want to know standard deviation. So the whole point here is to know what happens when you have a certain number of standard deviation. What happens if you have 10? What happens if you have 50? For example, in this chart. Okay, so if you look here, right? Okay, 2 sets of data data collection could have the same mean. So for example, let's assume we have two sets of data, okay? The red one and the blue one. If the red one and the blue one can have the same mean, meaning the middle point is 100, okay? So these two can have the same mean, but the standard deviation may show something else. So for example, I can have the same average, but the standard deviation, one is 10, one is 50, okay? If it's 10, if the standard deviation is less than 1, or closer to 1, sorry, if the standard deviation is closer to 1, that means expect a chart like this. All the numbers are concentrated in the middle, okay? If it's further from 1, expect a very wide range of numbers, okay, like this, like the blue one. Ideally, we would prefer the red one. That means we don't have too much variance, or we don't have too much numbers spread out on the data set. Okay. So just to summarize, there are two more things you need to remember here. Measure of central tendency, whereby the whole point is to find the location of the center of various distribution. I want to know what is the middle point, either through mean, median, or mode. But the most commonly used is the mean. Measure of dispersion, as the name said, I want to know how spread out the data values are on the number line. So we can do it with range, variance, and standard deviation, but most of the time we just use standard deviation. Okay? Do you need to know how to calculate standard deviation? No, you don't have to. So this is just an example. But if you want to, because of your MAA, then by all means you can do it. Alright, that is all. Thank you all.